Okay, so I believe that my screen is visible, right?
Yes, sir.
Yes, sir.
Okay. So the session is being recorded. Okay, so I will share the recorded session as well. But nevertheless, I will ask for your attention as much as you can. So in the last class, we finished ELD with generation constraints. The only thing we neglected so far was the transmission losses, and we did conclude that the transmission loss is not a constant, rather it is again a function of my generators or generating units. As such, it cannot be dealt so easily. So today we'll start with that thing, that is ELD with transmission losses. Well, it's a simplified diagram, nothing complicated over here. So you are giving fuel as input, F can act as your fuel, no problem with that. We can have our necessary you can assume, okay, let me draw. You can assume this to be your turbine blades. I mean, just simplified diagram. Okay, so this can be your fuel input. So this can be my turbine blades. You have your generators over here. Say this is your PG1, PG2, up to say you have got PGN. Okay, so the power you are getting is P1, P2, Pn. Then you have got your transmission network with P losses. Over here, you are seeing an example of a clustered load. That means we are assuming that the entire load is being clustered at this point, but in reality, you can have multiple loads over here. You can have loads over here. You can have loads like this. Okay, you can have a lots of loads, and in fact, all these transmission lines can or will actually be connected. Okay, your entire network will look something like this. So this is what your transmission network typically looks like. So if you recall, this is a type of diagram that we saw in our previous slide, right? Optimal power flow diagram. Power flow diagram, you remember that, isn't it? You have solved this type of diagrams, right? Isn't it?
Yes, sir.
Yes, sir.
So these are nothing new to you. Anyway, so the bottom line, as we established in the previous class, that is our P loss will actually be some function of my PGIs. So let's see how we calculate these things. All right. So my equation stands still. My objective function is CT, which is equal to the summation of all the individual costs of all the generators. And now my constraint becomes PD plus P loss. Now we are still neglecting the generator limits. Okay, we are now neglecting that. So let's see how it looks without considering the generator limits. So over here, we'll only have one objective function, which is my f of x, and I will have only one equality constraint. I will not have any inequality constraint. So if you remember, we solved this type of examples where we have to form the Lagrangian, then we have to go for finding the gradient. The gradient needs to be equated to 0, and as such we can, I mean, we can find out which is the minimum value. Okay. Okay, ID 205. Okay. Okay, someone please remind me. I think all of you have seen the message. So someone please remind me about ID 205 at the end. Okay, I have to balance the attendance somehow. Okay. Fine. So I think so far we don't have any confusion. So let us see how we form. So again, first of all, we form the Lagrangian. So we know that Lagrangian means it will be a function L, which will be a function of PGI and lambda. So we form the Lagrangian. So I have my f of x over here as beforehand, and I have my equality constraint over here multiplied by lambda. And if you can recall, this is your penalty term. So what was my first approach to find the gradient? That is partial derivative with respect to PGI. So if you do a partial derivative with respect to PGI, so again, you know how this became a full derivative, right? We saw the proof. You remember, right? How it became from partial derivative to full derivative. Do you remember?
Yes,
Yes,
sir.
sir, because it only depends on the one function, one
Exactly.
independent variable.
My generators are independent of each other. As such, from partial derivative, it becomes a full derivative. Now, previously, this term became 0 because my PD was not a function of any PGs, right? So previously it became 0. Now, since I have another term which is P loss, and I know that my P loss is a function of some PGIs, I cannot make it 0. So what I have to do? I have to find the partial derivative again. So if I find the partial derivative, lambda comes out, no problem with that. Partial derivative of PD with respect to PG becomes 0. Then P loss with respect to PGI, what does it become? What does it become? Let's see. How do you solve? I mean, how are we getting this minus and this minus? Tell me.
Sir, can you please repeat this part again?
Oh, okay. Let me erase this entire portion. Okay. So my question is, how are we getting this minus over here and this minus? What is happening over here? Tell me. Anyone? Why are we getting a minus? No one?
Due to
Sir, does the whole
summation of
term
PCI.
decreases the power loss? Is that
Oh,
why
it's,
we're
I mean, it's gradient. It should come from your derivative derivation concepts, gradient concept. Not, it has nothing to do with that penalty term and all. We are just finding the derivative, right? Okay, so let me do it again. So if I expand this, what do I get? Lambda into PD plus lambda into P loss minus lambda into summation of PGIs, where I is equal to 1 up to M. Okay. So I need to do partial derivative of this thing with respect to what? PGI, right? Is it okay? So
Yes,
this term becomes 0, no doubt, right?
Yes, sir.
Okay. What happens to this term? Lambda comes outside. You get di P loss by di PGI. Okay. You have got a plus over here. So I got 0 plus this. Is it okay up to this much?
Yes, sir.
yes, sir.
Then you have got minus lambda. And what is the partial derivative of PGI? How much did you get?
One.
From your previous class, we had this. We did this derivative a lot of times.
-1.
So you get a -1. So you end up getting what? You end up getting lambda di P loss by di PGI plus lambda tai ki. No, you're supposed to
It should
get
be
1 minus.
+1.
That would be 1, sir, I think.
What did we get? Let's check back. So I think we did this thing. Right? It was proved. It was, nope, it was minus. Right? You see, lambda gx over here. So we got a minus. So we did get a minus. Sign ulta hocche কেন?
স্যার ওই মাইনাস
Did-
সাইনটা স্যার ওই যে মাইনাস পিজিআর আগে যে মাইনাসটা হচ্ছে স্যার ওইটাই স্যার ডাবল স্যার গুণা হচ্ছে স্যার
Yes, sir.
বুঝি নাই। The minus sign?
স্যার
Say again,
মাইনাস
repeat
সাইন
again.
সামেশনের আগে যে মাইনাস সাইনটা আছে স্যার এটাই স্যার ডাবল গুণা হচ্ছে স্যার তাই প্লাস হয়ে যাচ্ছে স্যার
Yeah, so I mean, this derivative is right so far, isn't it? So you are getting a plus over here, right? You are getting plus lambda, right? Or not?
স্যার সেকেন্ডটা স্যার প্লাস হবে না স্যার সেকেন্ডটা মাইনাসই হবে স্যার
স্যার ব্র্যাকেটের ভিতরে +1 হবে।
এটা plus 1 হবে?
জি স্যার।
Sure, everyone?
Yes, sir.
How is it becoming plus 1? How is it becoming plus 1?
স্যার মাইনাসটা আসতেছে ল্যামডার
Summation-
সামনে মাইনাসের জন্য স্যার।
স্যার ব্র্যাকেটের ভিতরে তো স্যার PG1 প্লাস PG2 প্লাস PG3 স্যার এরকম না স্যার, তো স্যার ওটা প্লাসই হবে স্যার,
Right.
ডিফারেন্সিয়েট
Thank you.
করলে যে কোনো একটা
Very
রেসপেক্টে।
good. So what is the difference actually? Previously, when we did this thing, what was our expression? Our expression was PD minus PG1 minus PG2. Then we did our partial derivative with respect to PG1 or PG2, right? Isn't it?
Yes,
Yes,
sir.
sir.
So that's how you got a -1 every case with respect to PG1, with respect to PG2. Every time you got a -1, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now what is the difference? So now tell me, now what is the difference? It is still minus summation of all the PGs, right? So that means minus PG1 minus PG2 minus PG3 and so on. Say that I've got 3 units. So now if I'm differentiating with respect to PG1, what am I supposed to get?
Minus
-1.
-1.
Then how am I getting +1 now?
Sir, the minus is in the beginning. That
Right.
মাইনাসটা
lambda
আমরা
is
Thank-
শুরুতেই দিয়ে
the
দিছি।
minus
Thank you. So now actually it is like this, right? So this minus is over here. So this minus is actually over here. So over here you will have a minus. So in reality, if you do this derivative, then this minus is coming over here and this partial derivative is giving you a +1. So that's why you get minus lambda plus 1. Is it clear or should I again explain? I think I can expand if you have confusion. Should I expand?
It's clear, sir.
Sir, can you explain
sir.
the derivative again?
Okay. Okay, fine. Okay, so we are only interested in this portion, okay? So in this portion only. So I know that the partial derivative of lambda PD is 0. There is no confusion about that. The partial derivative of lambda P loss will be lambda di P loss by di PGI. Okay, there is no confusion about that. Now the last term I have is the partial derivative of my PGIs. Say you have got 2 units. So what is PGI? It will be PG1 plus PG2. So if you do partial derivative with respect to PG1, what do you get? Simply 1, isn't it? And if you do partial derivative, okay, if you do partial derivative PG1 plus PG2 with respect to di PG2, what do you get? You get another +1, isn't it?
Yes, sir.
So that means what? This term, if you do partial derivative, it will give you +1. Is it clear up to this?
Yes.
Okay. So now this term is becoming 0. This is giving you lambda di P loss by di PGI. Then you have got your minus over here. And this term is giving you +1. You have got multiplied with lambda. So you get lambda. So from this line, I think the next line should be very clear. Is it okay now?
Yes, sir, it's okay.
Okay. Okay, so I can erase all the slides over here. All right. So I get my gradient. So if you just change the side, what you can see, you can write that DCI by DPGI plus lambda di P loss by di PGI is equal to lambda, right? You can just take this lambda in this side after multiplying with 1 and you end up getting this expression. And what is the next thing I have to do? I have to again do the partial derivative with respect to lambda. So again, so if I do partial derivative with respect to lambda, this term will definitely become 0. All I will have is this term, that is PD plus P loss minus di PGI equal to 0. Clear up to this?
Yes,
Any
sir.
question, please ask. Any question?
Yes,
How I got the coordination equation? Is it clear? Okay. So if this is clear, okay, so if this is clear, now we need to look at some expressions. So there are 2 approaches how we can find the solution to this problem. One of the approach is loss formula method that we will learn over here. The another approach is optimal power flow method. So unfortunately, this will not be covered, but those who of you have taken power as your major, I think in the next semester you will get an optional course from Ashik sir. So over there you will learn about optimal power flow. But in this course we will only learn about loss formula method. So the best way is, let's take an example. Okay? So we learn using an example. So we are familiar with C1, C2, C3. We have no problem with that. We are given 3 expressions of 3 generators. We have our PD, total demand is 850. All we need is my P loss. So you see now, P loss is some quadratic function of your PG1, PG2, and PG3. Now P loss could be given in a number of ways. How we got this expression, there is a derivation, big derivation, which is there in Hadi Sadat sir's book. So if you want, you can go through the derivation, that's totally up to you. But for understanding our approach, that is understanding the how we find the solution to ELD problems, this is not that significant. However, if you are interested, you can go and find out how this expression came of P loss. So the bottom line is, we have got 3 expressions of 3 generators, and we got our equality constraints. That is the summation of your if I'm writing summation, I don't need to write this. So what is my equality constraint? If I want to write, my C1 plus C2 plus C3 should be my PD plus P loss, where my PD is 850 and P loss is given over here. So is the question clear to all of you?
Yes, sir.
Sir.
Now let us try to see the solution. So what we did, we applied the coordinate equations. Do you remember this equation we saw in the previous slide, few slides back, that dCi by dPgi is equal to lambda 1 minus di P loss by di PGi. Do you remember this
Yes, sir.
expression, or I can show it again? You
Sir.
remember, right?
Yes, sir.
Okay. In the left hand side, what you have to do, you have to find full derivative of dC1 first of all with respect to dPg1. So if you do that, how much will you get? This will become 0. You will get 7.92 plus this will be multiplied by 2 into PG1, right? So you
Yes,
get 7.92 multiplied by 2 into PG1. On the right hand side, what you have got lambda, you have got 1 over here, minus P loss by PG1. So you have your expression over here, P loss by PG1. So now if you do derivative with respect to PG1, then nothing will come from PG2 or PG3. You will get 0.0006 into PG1. So you get 2 into 0.0003 into PG1. So essentially 0.006 into PG1. So similarly, we get these 3 equations. This is with respect to PG1. This is with respect to PG2. This is with respect to PG3. And then you have got your equality constraint, just what I wrote beforehand. Clear up to this?
Yes, sir.
Any confusion? So you see now the problem statement is pretty clear. How many variables do I have? Tell me.
Sir, 4.
4.
4, right. So what are those? PG1, PG2, PG3, and lambda. And how many expressions do I have?
4.
Sir, 4. Expressions.
So it's very simple, right? I mean, can we solve it? 4 expressions and 4 unknowns. Can we solve it?
Yes, sir.
Yes, sir.
Sir,
Yes.
sir, P loss will be given as data.
I mean, P loss is dependent on PG1, PG2, and PG3. So you don't have any new variable, right? If you can just find the values of PG1, PG2, and PG3, then you can also find your P loss. If I go to previous slide, you see your P loss is given as some function of PG1, PG2, and PG3. Right? So if you
Yes,
have
sir.
4 expressions and 4 unknowns, can you find it? Again, I'm asking the question. Can we find it?
Yes, sir.
No, sir. The P loss
There
is
is
a
a problem,
nonlinear
sir.
equation.
What is
Sir,
the
Sir,
problem?
The P loss
depend-
is PG1 squared, P something PG2 squared plus something
Nonlinear equation, basically.
non-linear.
Okay. Okay. So let's say we have got one problem, that is this expression is non-linear, right? The expression of P loss, isn't it?
Yes, sir.
Yes, sir.
Anything else? Any other problem we have?
Another thing is that lambda is multiplied with PG1 and PG2 and PG3.
Okay, so if it is
That's also a
multiplied,
problem.
Why is that a problem? If lambda is multiplied with pg1 or pg2 and pg3, then why is it a problem?
Lambda is also a variable, so the whole thing is non-linear and it's
Very
not
good.
easily
This is
solvable.
what I was expecting. Thank you. I got the answer now. This is what I was expecting. Okay. It is true. We got 4 expressions and we have 4 variables, but the problem is the set of expressions that we have is not a linear set of expression. Rather, it is non-linear set of expression. So we cannot solve with any known method that we have. So we have to go for some other technique. Is it clear what is the problem, everyone?
Yes,
Is it
sir.
okay? Okay. Now there is one more thing that you have to
Yes,
know.
sir.
That is, say if j is your iteration number, okay, you have to follow the iterative method. So if j is your iteration number, then these pg1s should have an index of j, and j. If this pg1, pg2 and pg3 are j, then this pg1, pg2 and pg3 are your j plus 1. That means what? For solving, again, these are your j plus 1, j plus 1, j plus 1. That means for solving this type of method, this type of problems using iterative method, we always need initial value. That means what? Say, for your first iteration, okay, say when j is equal to 1, these values from where will you get? Because you see the normal convention. Your j is your, okay, let me change the convention a little bit, then it will be easier to explain. So j is your iteration number, that's fine. J is your iteration number, that's fine. In that case, if these are j, then these are j minus 1. Okay. So that means if you are in the present iteration, then you need the value of pg1, pg2 and pg3 from the previous iteration. In that case, when j is equal to 1, as you know in MATLAB, we cannot start from j equal to 0, right? Your index has to be 1. So if you start from j is equal to 1, what is the value of your pg1, pg2 and pg3? What do you think?
Initial values.
Very good. Initial values. So for solving this type of problems, what we need? We need some initial values. Okay. So we will assume some values of pg1, pg2 and pg3. Based on that, you will find the value of this pg1, pg2 and pg3. Is it understood? What is our approach? Are you understanding where I'm going? What I'm trying to say?
Yes,
Yes,
sir.
yes,
Yes,
sir.
sir.
Okay, then tell me, when do we stop? This method could keep on going, isn't it? Every time we go to the next iteration, my present value becomes my past value. I find the new set of values. So the new set of values becomes the past value for the next iteration and so on. So when do I stop?
When the values will converge to a certain value, we will see that the values will not change that much after certain iterations.
Okay, right. So what we need to see that my PGI, say for j plus 1 minus my PGI for j, you can give modulus over here. Okay, that is the difference of these two will be less than epsilon, where epsilon is some value which is known as my threshold, or I forgot another term. There is another term as well. Right, tolerance. Yes, it can be
Tolerance.
tolerance. Yeah, it can be tolerance as well. So it depends that how much is your tolerance, how much error you will tolerate, or how much you want to consider. So that is known as your threshold. So if this difference becomes less than your epsilon, then you stop your iteration. Otherwise, you keep on going. Okay. So let's see. The solution is given over here. So let's see. So the first step, we know we have to go for some assuming initial values. Based on that, we'll find the values of the next iteration. So this thing is given over here, whatever you have just said. So see, everything is written over here. So you have to pick a set of starting values for PG1, PG2 and PG3 that sum to the load. Okay. Then we have to calculate the incremental loss, die P loss by die PGI. So if you see, die P loss by die PGI essentially is your this portion. You have to calculate this die P loss by die PGI, or I can say that only this portion. Why only this portion? Because you see only this portion is related to your initial value. Your rest of the parameters are not related to your initial value. Okay, so only this portion is related to your initial value, as well as total P loss. Because P loss I did not write over here, sorry. So P loss is again a function of j minus 1. So again you have to calculate this term only. So these two terms you have to calculate. Okay, so based on whatever you considered in this first step, whatever values of PG1, PG2 and PG3 you considered, based on that you will find the value of your dip loss by dipgi and the value of P loss. The incremental loss and total loss will be considered constant until we return to step 2. Okay, forget about this. So calculate the value of lambda that causes PG1 plus PG2 plus PG3 is equal to PD plus P loss. So you have this expression. So over here you have to calculate the value of your lambda. This will also yield new values of PGI. Basically you will solve all the 4 expressions now, because once you have the value of dip loss by dipgi, it becomes a linear set of expressions. So if you have a linear set of expressions, you will find the value of your PG1, PG2, PG3 and lambda. Then compare PG1, PG2, PG3 from step 3 to the new values used at the step 2. If there is no significant change, then go back to step 5. That is done. Otherwise, we have to keep on doing. So let's see what we do. It will be way more clear when we go for examples. Okay, so what is the value we are picking? We are picking PG1 is equal to 400, PG2 is equal to 300, PG3 is equal to 150. Remember, there is no restriction on how you pick your PG1, PG2 and PG3. If you want, you can pick 005. I don't have a problem with that. If you want, you can pick 000. Anything you want. But whatever, I mean, it depends how realistic your initial value is. The more realistic your initial value is, the less number of iterations will be required to converge. Okay, so if you deviate from the realistic values, you will see that your convergence will take a lot of time. So okay, so what is the value we are picking? 400, 300 plus 150. How are we picking those values? There is one simple thing that we are trying to follow. That is, I'm trying to see my PD over here. See, what is my PD? 850. Okay, so based on that, you see that if you sum up 400 plus 300 plus 150, you end up getting 850. Is it understood how we picked our PG1, PG2 and PG3?
Yes, sir.
What could have been a more realistic approach? If you would have picked PG1, PG2 and PG3 such that the sum is a little greater than 850, isn't it?
Yes, sir.
Right? Because you know that at the end of the day, you have to incorporate your P loss as well. So what you could have done is, instead of picking 400, instead of picking 3 values which sum to 850, you could have picked 3 values which is slightly more than 350, slightly more than 850. But then again, if you exceed the P loss, that's fine. Your iteration will give you, will bring you back. All right, fine. So we picked up some initial values based on that 850, that is PD. We calculate the incremental losses, that is dip loss by dipgi. So we know that dip loss by dipgi, the expression was this, where over here we had our PG1. So now PG1 is 400, so we plug in 400. PG2 is 300, we plug in 300. PG3 is 150, we plug in 150. So I get my dip loss by dipg1, by dipg2, dipg3, and I get my P loss as well. Any confusion up to this?
No, sir.
How did I get my P loss? How did I
So
write
using
P
the
loss is
formula
equal to
P loss.
Right, the formula is given, right? So what was the formula? Here, 0.003. So what you did, instead of PG1, you wrote 400, I think, whatever we assumed. Then this was 300, I think, and this was 150. Yeah. So these were the values. So if you plug in these values, you will get the value of your P loss. So now I have got dip loss by PGI, dip loss by PG2, by PG3. Now if I get back to these expressions, what do you have? Instead of this value, you have got a constant value, right? What is the value? 0.0240. So this value you got, sorry. So this value you got 0.0240. Similarly, this one is also a constant. This one is also a constant. And you got the value of your P loss as well. So this is also a constant. Now, do you have any non-linearities anymore?
No, sir.
No, sir.
Is there any non-linearity? No, right? So now you have got your 4 sets of linear expressions and 4 variables. Can you solve it?
Yes, sir.
Okay. So see, this is your expression. When you plug in the values, you get your 4 sets of linear expressions with 4 variables. Now you can solve. The matrix method is shown over here, so no problem with that. So you get the solution. So let's see, what are the solutions that we got? What was our initial assumption? Our initial assumption was my PG1 was 400, PG2 was 300, and my PG3 was 150. So is there a significant difference between the two PG1s? So now this is your PG1, this is your PG2, this is your PG3, and this is your lambda. So is there a significant difference?
Yes, in PG1 and PG3
Yes, sir.
there is significant.
Right. In PG1 and PG, remember these all are in megawatts, right? So there is a significant difference between PG1 and PG3. That means now you will enter your second set of iteration. So now this becomes your, I mean, if these were your initial values, this is now your iteration 1 values. So now you enter the second iteration. So what, again the same method, right? You get back to step 2, that is you calculate your dip loss by PGI and P loss. So now instead of plugging 400, what you plug in the last values of PG1 and PG2 and PG3 that you got. So you got 440.68, 299.12 and 125.77. Again you calculate your P loss and you solve for the next iteration. Okay, so what was my previous values? Let's see. I got 440.68. So the values I got are 440.68, then it was 299.12 probably. What was the last value? 125.77. 125.77 and probably 9.75. So is there any significant difference now? Is there any significant difference?
No, sir.
No significant difference.
So if you consider megawatt, it is still very
Of course, there is
large
a significant difference, right? This is 440, this is 433. There is a difference of 7 megawatt. This one might be considered fine. Then 125 and 131. So you have got difference of 6 megawatt. And this one might be fine. But we still have. So what you have to do now, this becomes your second iteration value. So this becomes the value of your second iteration. With these values, you enter your third iteration and you keep on going. So what do you get now? See. So this was the values of your first iteration. This was the value of your second iteration up to which it was shown. If you go for the third iteration, this is what you will get. Still you see. So sorry, iteration ulta bolte si. So this was the value of my first iteration and this was the second iteration up to which you guys were shown. Now this is your third iteration. So you see there is still significant difference. If you go for the fourth iteration, there is a gap of 2 megawatt. This one might be okay. This one 1 megawatt, fine. We could still try to reach more closer, but there is a significant gap in PG1. So when you enter the fifth iteration, now you see, now this is a bit close. So now this can be considered, this is fine. These two are fine. These two are again fine. These two are again fine. So now we can say that finally it converges in the fifth iteration. Is it understood?
Yes,
Yes, sir.
So this, I mean, if you need more number of iterations, now it depends on what. Again, you see, you finally ended up having 435, 299 and 130. So it depends what was your initial values. So if your initial values would have been like this, 433, 300 and 131, something like this, then you would have needed only 2 iterations to converge. So it depends how close you are in choosing your initial values. Is it okay?
Yes, sir.
Any question? Come on, you should have some questions. No question?
Sir, in the exam, will the max number of iterations be given or the starting initial values?
That's what I was expecting, that you should ask something related to your exam, because this is a pretty big math. If you need 5 iterations, for each iteration you need to solve a 4x4 matrix, maybe, which will not take so much time because you can solve a 4x4 matrix using your calculator. But if it's a 5x5 matrix, then you need to solve that for 5 times, right? So it will consume a huge amount of time. So what I will do in the exam, I still don't know. But one thing is for sure, I'm not going to give you the initial values, because it is again a test, how you assume your initial values. So based on that, some of you might need 6-7 iterations, some of you might need just 3 or 4 iterations. So it depends, I mean, how you are thinking, how much realistic values you can consider. All right, what I will do, maybe I will try to keep the problem simple so that you don't go beyond 4x4 matrix. But again, I'm not promising that. It depends how much marks I'm allocating, or if I solve it on my own. It depends. I mean, I've not yet made the question. But the bottom line is, if you have this type of problem which includes your P loss, then if you follow the iterative method, it is going to take you some time to solve it. And probably this is our last topic. Yes, this was indeed our last topic of ELD.
Sir, the initial values, there can be a lot of combinations. So
Right.
below the value of PD, any combination is suitable?
Yeah, you can go for that. But if you go with that, I think, just a second. When we
Sir, is
assume
there
the
any risk of the answers getting diverged if the
Exactly.
initial value selection is very
See,
wrong?
your step 1 says that pick a set of starting values of PG1, PG2, and PG3 that sum to the load. So the condition is already given. Your load, whatever is your load, you have to consider your PG1, PG2, and PG3 such that it is equal to the load. Okay, so if your load is 850, you have to consider your PG1 and PG2 and PG3 such that it is 850. Okay. Any other question? Any other question? Come on.
Sir, if
Sir,
our
is there
values start to diverge, indeed, then can we leave off the iterations at 4 or 5? Because after that, it is very tedious to continue.
Typically, it is not supposed to diverge. The way this thing is designed, it is not supposed to diverge. It is supposed to converge. But if you see that it is indeed diverging, then I will suggest you stop after few iterations so that I at least know that you know the process. Then we'll try to find out why it did not converge. But it is supposed to converge. This is how it is designed. It is not supposed to diverge. Any other question?
So depending on the capacities of the generators, G1, G2, and G3, is there any guess we can take for the initial values?
You could have taken a guess for the initial values if you would have included the constraints, inequality constraints of the generators, like your upper bound and lower bound. Since those things are not there, those things are not included, so it is very difficult to guess, I think. Like, you had no idea, right, that PG1 will be contributing more than PG3. You see, PG3 is contributing 130, PG1 is contributing 435. We had no idea to guess it, right?
Yes, sir.
Sir,
So,
while performing the calculation, do we necessarily need to draw a table for each iteration, like 1, 2, 3, 4, 5? To draw a table while calculating everything, to make a table just like this? Is it
making a
necessary?
table, no, making a table like this is not necessary, because if you do something like this, like at the end of each iteration, if you can just show the comparison between your values obtained in the previous iteration and the present iteration, and if you can just say that fine, the difference is, or the epsilon value is satisfactory or not, if you can just say this much, it's fine. You don't have to go for making a table like this. You don't have to do that.
Okay, Roger, sir.
Anything else?
Sir, we will have only one problem for the quiz, right?
হবে জানি quiz on Tuesday you have got your quiz, right?
Yes, sir.
Whether you get one problem or two problem or three problem, definitely I need to keep it in mind that you will have approximately 15 to 20 minutes to solve. So I'm not going to give you something that you cannot solve between that time. Okay.
Thank you, sir. Yes, sir.
Anything else?
Sir, how much mark does the process carry? Like, if the process is correct, how much marks are we
Okay,
supposed to get even if the
these are
values are wrong?
questions. Okay, these are questions related to partial marking, right? And see, I
Yes,
have not
sir.
yet made the question. I have not yet started seeing the script, so I still don't know. This answer you will get when you will see your midterm scripts, and maybe before your midterm exam. Typically, the last class I discussed the question pattern and how you should approach the question. So maybe during that time, when I have made the question, I know what is the solution. Maybe during that time I will be able to answer these things. But as of right now, if you have any confusion related to this, I mean, the things that we learned, if you have any confusion related to this, you can ask. Because marking and all, I still don't know how I'm going to do that. Okay. So forget about the quiz. I mean, forget about the marking. If you have any question in this problem or something, then since I said that this is the last topic for ELD, I'm expecting some question, at least one question. When I said that this is the last topic, there should be at least one question. Just a second. Okay. I accidentally stopped sharing. Sorry. Let me share again. So you don't have any question, then let me. I will be asking you a question. If you don't have any question, what do you think the question I'm expecting? What is the question that I'm expecting?
Sir, how did we minimize the cost?
No, that is very simple. The approach is there, iterative method.
Yes,
So
sir.
that is how you minimize the cost. That is not a question.
Sir, why
No,
did
sir,
we
what will
suddenly
be
remove all the inequality constraints?
Right. Though that is not the exact question, but that is something that my question is, what will happen if now I include my P loss as well as my inequality constraint? That is the only criteria we did not satisfy, isn't it? Right? Apart from that, we covered pretty much everything. But the total picture, if you say the total picture, then you have got equality constraint, which includes your P loss. You have got your inequality constraint, which includes your general limits. So what if we include everything? What will happen then? How do you solve it? Okay, so that is something we did not cover in this course. The reason is that up to this, whatever you have been taught, this is classical optimization, something you will never apply in your real life, honestly. Okay, these methods that you are learning, iterative method, then Lagrangian method, all these things you are not going to apply. But what these things give you is how to formulate an optimization problem. Okay, how an optimization problem is formulated. The last problem, I mean the last approach that you saw, the iterative method, it is the closest one to the modern methods that we follow nowadays. It is the closest one. So do you remember in the first class I told you about meta heuristic algorithms? Do you remember that?
Yes, sir.
Okay, so when you incorporate everything, or when you have some kind of optimization problem, once you have formulated your equations, you will follow the meta heuristic algorithm. That's for sure. You are not going to follow this gradient method, Lagrangian method. You are not going to do that. So how your meta heuristic optimization algorithms work? It is a type of iterative method, okay, which is a close resemblance to the last method that we solved. So you will see that you will have some initial values. Based on that, in the second iteration, you will consider or you will calculate the values. Then those values will be your initial value for the next iteration, and it will keep on going until and unless you converge. So these examples, why we solved these classical examples, because up to this is something that you can solve with a pen and paper during the limited time in the exam that you have. If I go for meta heuristic algorithms, those are something you need some software to solve, like MATLAB. You cannot solve that using pen and paper during your exam hall. You need some machines to do the calculations, right? So that's why this thing is formulated, so that you at least know how an optimization problem is formed, how classical optimization algorithms typically deal with this type of problems. Okay, so you have got some idea. So in the next phase of your study, or wherever you do, whatever you do, If you ever come across, or if you start learning about your meta-heuristic algorithms, then you will get a complete clear picture. Once you learn your meta-heuristic, you will see that there is no limitation on the number of inequalities or equalities or the number of variables. It doesn't matter. Simply, it doesn't matter. But over here, you see that it becomes more and more complex. The more number of variables you include, the more number of inequalities you include, it becomes more and more complex. But that is not true for your meta-heuristic algorithms. All right, so this will be all for your quiz. Again, I'm saying the question in the quiz will be such that it can be solved within that 15 to 20 minutes. But don't forget to bring your calculator. If you forget to bring your calculator, you are never going to be able to solve. Any question?
Sir, in the quiz, do we need derivation or only mathematical problem will be enough? So for the quiz only.
For the quiz, anything might come from your ELD slide or based on ELD slide. You know that you will not get exactly the same thing. So you will get something from it might be derivation, it might be a derivation and a math problem as well, or it might be a simple math problem as well. It depends. The bottom line is I'm not going to tell you, so that because I want you to study everything. Anything else? Nothing?
Sir, you said the quiz on Tuesday.
As far as I remember, your CRs told me that yes, it will be on Tuesday, right?
Yes, sir. It is on Tuesday, sir.
Yeah, it is on Tuesday. Is it okay if we take it on Tuesday?
Sir.
Okay.
Sir, am I audible?
Yeah, you're audible.
So basically, we received the referred exam schedule last day. I guess 6, 7, 8. There are referred exams and in 2 shifts. So that actually creates a problem in that sense. When we are deciding for Tuesday, we didn't receive the schedule then back then.
Right.
Yes, we received it today, sir.
Yeah, I saw. Today we received the referred exam schedule. So is it going to create a problem? Some of you have got referred in the afternoon.
Yes, sir.
So what do you suggest? What can we do?
If it is possible to do it next week, the beginning of the next week.
Yes, sir, if that is
Will you
possible,
have-
sir.
Will you have time for a second quiz then? We need to have at least 2 quiz before your mid. And if I don't take this quiz and we start new topic, there is a high probability that you will forget all these things.
So
But I understand that your referred exam is also creating a problem over here.
Obviously, sir, the exam for the refer is very tight. Some can even have maybe two courses in one day. That's huge. It's like morning, afternoon, again, you go back for another course. So which means the week within will be so tight, actually.
So you have to shift it by 1 week.
Yeah, and
Yeah,
maybe
maybe
it's possible to do it online.
Give
No.
quiz, If not online, but when you give quiz by next week, maybe the topic that we will start after ALD, it can be the following week before the week. For example, when you give quiz by next week, then the next topic that we will start for next week will be part of the second quiz that will be announced for the following week, probably.
Yeah, I got your solution. Okay, fine. I think if I want to consider your problem, then the only solution is to shift the quiz by 1 week. There is no other feasible solution.
Probably we can go in for that, sir.
Okay, then I'm shifting it by 1 week, but please don't come up by saying that we have got a lot of quiz on that week as well. You cannot say those things. Okay.
Okay, sir.
So that means next to next Tuesday. Wait, let me finalize the date. Wait. That means we were supposed to have our quiz on 6th, but instead we are having it on 13th, right? 13th February.
Yes, sir.
Okay. So
Yes, sir.
13th February is final. You cannot change that. The CRs, you there?
Yes, sir. I'm booking the rooms.
Okay, so you book the rooms and you make sure that you don't have any other quiz on the same date. I mean, do not come to me for changing it again. So your quiz will be on 13th of February, the first quiz. Remember, the second quiz must be taken within February. That means, so you can book the date. So on 13th we are having our first quiz, and on 27th we need to go for our second quiz. Okay,
Yeah, in
because
fact, that
after
would be
that week
preferable,
maybe
sir.
you'll have your mid. Are you getting me?
Yes, sir.
So 13th first quiz, 27th second quiz. Is it okay?
Yeah, that's better. Sure.
Yes,
Okay, CR. So you book both of these dates for me, 13th and 27th, both on February.
Sure.
Okay.
Now we leave
Alright.
it to Allah's disposal. We make our proposal. I say we make our proposal, we leave it to God's disposal.
That is the ultimate truth.
Yeah, that's the truth. We don't know what will happen for the day.
Hope for the best. See, I mean, I'm trying to accommodate as much as I can. Okay, that is the best I can do.
So that's the truth. That's the truth.
Okay, just a second. So let me just take your attendance, and after that I'll let you go. Okay, let me stop recording.